This is question number 21, and it is asked here, what is the harmonic conjugate of uxy? So uxy, this is a function of two variables, and the function is 2x minus x cube plus 3y square. We have to find out the harmonic conjugate function of this function. Okay, so here first we have to check whether this function u satisfies or doesn't satisfy the Laplace equation. Okay, so this is uxy, and this is Laplace equation. Del square u by del x square plus del square u by del y square. Uh, and so this is the Laplace equation. If this equal to 0, this equal to 0 is the Laplace equation. If this function satisfies if uxy, this function satisfies the Laplace equation, then uxy is said to be harmonic function. So we will check whether this function is harmonic or not. Okay, so first we have to find out the first order partial derivative, and the first order partial derivative of this is 2, and this is with respect to x. So 2, this is 3x square, and 3x square will be is a constant, 3y square is constant here, derivative of x is 1. So this is, and this is del u by del y. So del u by del y, so this is x term 0, x term 0, and this is x. So x is constant here, and the derivative of 3y square with respect to y, this is 6y. So this is 6xy, and derivative of this is 6x. Okay, so because this is y term constant, so this is so here this is constant, so this is 0 and this is 0, and this is 3y square, 6x, derivative of 3y square with respect to x, this is 6x, and this is del u by del y, that is 6xy, so it is 6x. Okay, then we have to check it here. We will add this 2, obviously by adding this 2 we are getting 0. So this function is satisfying the Laplace equation. So so this function is a harmonic function. Clearly uxy is a harmonic function. We have to find out here in this question, we have to find out the harmonic conjugate, function of uxy. Okay, let the harmonic conjugate function of uxy is vxy. So we will use this formula, to find out the harmonic conjugate function of uxy. Okay, so this is we will use this formula. So dv, so if we will find out dv, then when we will integrate, integrate dv, when we will integrate this both side, this equation both sides, so then we will get the value of v. So v is the harmonic conjugate of u. Okay, so dv is equal to, this is del v by del x, into dx plus del u by del y into dy. So here you can see this is del v by del x, but we don't have del v by del x. Okay, so you can see this is u term and this is u term. We don't have a v term here, but here it is given del v by del x. This is del v by del y. So we will use CR equation, and this is u term, this is v term here. We will place a u term here instead of this v term. We will also place a u term here instead of this v term. So by CR equation we will do it. So you can see this is del v by del x, so it is equal to del u by del y by CR equation, the second equation. Okay, CR second equation, which is uy is equal to minus vx. Uy is equal to minus vx. You can see uy is equal to, if minus sign will come to u side, so minus uy is equal to vx. So by CR equation we replaced it, and this is del v by del y, and this is del u by del x. We will replace it in the first CR equation. Ux is equal to vy, ux is equal to vy. Okay, so then we will integrate both sides of this equation. So if you will integrate, uh, if you will integrate, so then we'll place it, then we'll place it. You can see del u by del y. Okay, del u, where is this? Del u by del y, it is a 6xy. So here it is minus, here minus sign is there, so minus 6xy dx. And this is del u by del x. You can see del u by del x, this one. So del u by del x. Okay, so we will find out the harmonic conjugate of this. We'll integrate both sides. Okay, integration of this equal to integration of this. So integration of this is equal to v. Okay, so then we will integrate this. When we will integrate this, we will get, you can see, this is 6xy dx, 6xy dx. Now we have to find out the integration. Okay, so this is, you can see, this is minus 6xy dx, and this is 2 dy. Okay, so 2 dy, and this is 3x square dy, and this is 3y square dy. When we'll you can see, we this is there are two variables, x and y. There is also, you can see, there is also dy. Y variable is there, and with respect to y variable is there, and x variable is there. So you can see this is 2 dy. So simple, the derived integration of 2 dy, so 2y, and the integration, and this is y dy, the integration of this 3y cube divided by 3. So 3 cancels, so y cube plus y cube, and this is, you can see, so this is 2y and plus y cube. This is 2y plus y cube, and this is uh, and this is minus 6xy, minus will come outside. So minus 6 minus integration of 6xy, integration 6xy dx, minus integration 6xy dx, and this is 3y square, 3x square dy, minus 3 x square dy. So this is 2y plus y cube. You can see we can bring minus 3 common, minus 3 common, so 3 common, so uh, the 3 will come, we can take 3 common, and minus sign is also there, minus sign is also there, so minus 3 will come outside. Then uh, minus 3, so minus 3 came outside, and this became 2xy dx, and this is x square dy. Okay, so you can see, this is 2x square dx plus x square dy. We can write it d of x square y. You can check it. Then this is 2y plus y cube minus 3. Integration of d of this is equal to this. So it became minus 3x square y. So 2y, and the answer is, this is plus. Okay. This is 2y plus, so y cube minus 3x square y. Okay, plus 3. So plus 3. You can see 2y plus y cube minus 3x square y. 2y plus y cube minus 3x square y plus c. So this is the answer. So option B is the option B true. This is the answer. Option B is true. So now we will go to question number 22. So what is given in this question number 22? It is asked the real part of this. Real part of this. This is 1 plus I, the complex number, to the power 8, 1 minus I, it is a complex number to the power 8. So we have to find out the real part of this. Okay, so this is to the power 8 to the power 8 to the power 8. So we can write it 1 plus I to the power 2 whole to the power 4. We can also write it, we can write it 1 minus I to the power 2 whole to the power 4. Okay. So this is a plus b whole square, a minus b whole square, a square plus b square. So a square 1, no, I square minus 1. So plus 2 into 1 into I, and this is a square plus b square minus 2ab. So this is minus 2 into 1 into I. So 1 cancel, 1 cancel. So it became 2i to the power 4, 2i to the power 4. Okay. So this is, you can see 2 to the power 4, 16. This is I to the power 4. I to the power 4. So I to the power 2 is equal to minus 1. Minus 1. I to the power 4 is equal to I to the power 2 into I to the power 2. I to the power 2 is minus 1. I to the power 2 is minus 1. Minus 1 into minus 1 is equal to plus 1. So 16 into plus 1, 16. It is also 16 into this is also this is positive power, so the sign of this is plus. So this is 16 into I to the power 4. This is 1. So 16 plus 16, that is 32. So 32 can be written as 2 to the power 5. Okay. So 2 to the power 32 is a real number. So every real number is also a complex number. So how 32 is a complex number? So what is the imaginary part? The imaginary part of 32 is 0. 32 can be written as 32 plus 0i. So here 32 is the real part and 0 is the imaginary part. So it is 2 to the power 5. So it can also be written as 2 to the power 5 plus 0i. So 2 to the power 5 is the real part. So it is just what is the real part? 2 to the power 5 is the real part. So option C is true. Then we will go to question number 23. So it is